Hello, everyone, and welcome back to Microsoft Mechanics Live. Coming up, we're joined by Azure CTO Mark Russinovich to look at the future of application development and provisioning, from the ability to build portable apps that work across cloud providers and your on-premises infrastructure, and even devices at the edge, with something new called Rudr, our implementation of the new open application model, to leveraging event-driven, microservices-based runtime building blocks to execute your apps with new Distributed Application Runtime, aka Dapr, that works with any programming languages. And to help get started with this, please join me in welcoming back Mark Russinovich.
Thanks, Jeremy. Great to be back.
Thank you. All right, so you're doing all this work around building and deploying apps with both Dapr and Rudr. What are we solving for with this in terms of evolving application development, and kind of what's the go-forward direction here?
Yeah, so the goal of both the projects are to make it easier for developers to create cloud-native applications, and not just cloud applications that run in the cloud, but cloud-native applications that can run anywhere, on-prem, on the edge, or in the cloud.
Right. So why don't we start with deployment? I've got it in my Twitter handle. It's one of my favorite topics. So there are a lot of attempts, I think, in the industry in the past, and people have probably seen a few of these, where we try to get applications to run anywhere. But what's different now in terms of being able to run them across different clouds and make sure they work wherever you run them?
Yeah, well, so one of the key developments in the last few years is that the ubiquity of Kubernetes. Kubernetes works on premises, it works in the cloud. You've got managed Kubernetes services like Azure Kubernetes Service, and ones on other clouds as well. But that said, there's kind of a gap in the Kubernetes stack. It is infrastructure focused. And so that means when somebody's creating a deployment for Kubernetes, they're mixing application developer concerns in with operator concerns, in with infrastructure operator concerns. And so as a developer authoring one of these manifests, you've got to know all of these different concepts related to the infrastructure, which distract you from your core goal, which is to define the application.
OK, so we built something called Rudr. How do we make this better?
So Rudr is an implementation of a specification for describing applications called the open application model. And that model is intended to be portable, and also to separate the different roles that are involved with creating, deploying, and operating an application or an infrastructure. The goal, again, for both OAM is to support the application model that can target different infrastructures, and Rudr happens to be that implementation of OAM for Kubernetes.
It'll work both in, again, public cloud or on premises. So how does this, I'd imagine, how does this actually work in terms of being able to separate this across the different platforms or infras like we see here with Azure, AWS, Alibaba, et cetera? That will just work?
Yeah, exactly. So one of the patterns that we see, of course, is the full stack developer, the one that's doing DevOps, creating the application, deploying it, and operating it. But we also see other patterns as well. We see the one where there's a different operations team or SRE team that's operating the application, so the developer creates it and hands it off. We also want to support a marketplace scenario where there's a marketplace of applications or a service catalog for an internal organization.
Right, so I can imagine that in the future, you might have something like an app marketplace. We've got marketplaces on Azure, obviously, but imagine one that really went across any infrastructure. So you could pick the app that you wanted to run. You could make sure that it could run in Azure, AWS, we got here Alibaba, other clouds, on-premises, in a Raspberry Pi device. All of these things would work, right?
Exactly.
So how do developers then and organizations actually get on board with using the model itself?
Well, like I said, there's different roles involved with the creation of application. There's the developer, the application operator, and the infrastructure operator.
Right, so why don't we start with the developer? What does the developer do in this case?
So the developer is the one that would author a manifest. In the case of Rudr, it's a YAML manifest in OAM, which gives them a consistent model to describe the different characteristics of the microservices or components that make up their application. Things like which ones are the back end, which ones are the front end, which container images they reference, whether they need a load balancer, what their auto-scaling needs are, what their health signals are, and so on, that are developer concerns.
Right, and this is good because as a developer, you don't have to know Kubernetes or be completely fluent in how to write all of that, but you don't have to even target the infrastructure that you want at all.
That's right. You just specify the concerns from an application perspective.
All right, so why don't you talk us through what the app operator would do?
So again, when you've got this delineation of different roles, the application operator is responsible for taking that application description and then specifying the parameters and behaviors that are specific to the particular instance that they want. So they might have one that they're deploying in one production environment that is small scale. They might have another one in a larger environment. They're specifying things like what identity, what ports to use, what auto-scaling rules, whether the thing should scale up and down, and how far it should scale.
OK, so what about the infrastructure operator? What does their role then look like in this case?
So finally, the infrastructure operator is responsible for, of course, setting up and managing the infrastructure. In the case of a Kubernetes cluster, they would be responsible for setting up the ingress controller or controllers that are available in the cluster, right, the service mesh that's there, the auto-scalers. In the case of a public cloud platform like Azure, Azure takes care of it. We specify the load balancer, we specify the other infrastructure services, and manage them ourselves.
OK, so the infrastructure operator is then kind of making it real on their specific platform. So in other words, I can see how this might come together where effectively the developer would say they want an ingress solution along with a couple of other traits. The app ops team would then kind of figure out what they want to specify from parameters maybe more specific, like the different SSL requirements or ports that they want open. Then the infrastructure ops team kind of determines the specific services that they want to use. Like they might want to use Nginx, for example, if it's on-prem. But if you're an infrastructure operator that runs Azure, you might want to use the Azure load balancer.
That's right.
All right, so it's super clear delineation of roles so that operators really don't have to make guesses then about what the developer would have in mind. That means truly that we can finally write one app that kind of works everywhere, and they don't need to worry about infrastructure. But can you show us what this looks like in action showing Rudr?
Yeah, absolutely. So I've got here a very simple application. It consists of a front end and back end. What it's going to do is show a bunch of cubes with the front end, the back end managing the position of those cubes, the front end displaying them in a 3D.
OK.
So here's the code for the back end. It's written in Go. I've got the code for the front end, also written in Go.
All right.
And then I've got the application manifest here that describes how they relate to each other as well as the parameters that a developer would define for an application operator to make concrete when they deploy it.
Got it.
We've got two of these component schematics, each one to describe the different roles. Here's the front end role. And you can see down here in the spec that we've got some parameters. So this is where the developer said, hey, I'm allowing this thing to be parameterized. And one of the parameters they're allowing to specify is a texture, and that texture will be displayed by the front end on the spinning cubes.
OK.
Now on the front end also here you can see that OAM, or Rudr, takes those parameters and plumbs them into environment variables so the code can just simply read it.
Got it.
Then here on the back end, you can see that the back end has some configuration for the ports that it's going to be listening on for the front end to talk to it.
OK. So now if we want to then configure this to run on another couple of different environments, how does that look?
Yeah, so I'm going to go ahead and run this deployment script. This deployment script is going to take that application manifest that references those components, those front end, back end that are containerized, and deploy them to 3 different environments.
OK.
The first one is going to be Azure Kubernetes Service, or AKS. And here's the application operators configuration file, where they're deploying it to AKS. And now here's where they're specifying that they want a value, AKS, for that texture. So what that's going to cause is the code to go read an AKS image and display that on the cubes.
Got it.
And then you can see that here's a trait. This is where they're saying, hey, for ingress, for the ingress controller, whatever the ingress controller the infrastructure has, I want to use this domain name as the domain name for the application.
Got it. OK.
Similarly, here we can see another configuration file. This one is for EKS, which is the AWS managed Kubernetes service. So we're going to have it pick a texture that represents the EKS logo and also use a domain name that shows us that it's in EKS.
Right. But otherwise, it's identical. The important part is it's basically identical to the AKS one.
Yep. And then finally, I've got this Raspberry Pi cluster here. This is to demonstrate cloud and edge on-prem.
Right.
And I've got another configuration file for this one. We're going to specify a Pi logo as the texture, and then we're going to specify Pi as the domain name. So those deployments have finished. I'm going to go to the browser now. And I've got 3 browsers open, pages open, one for each of these. So this is the AKS one. I'm going to refresh, and we've got our spinning cube starting up here with the Azure logo, as we can see.
Nice.
And then this is on Elastic Kubernetes service, and we can see the AWS AKS logo. And then finally, right here on these Raspberry Pis, there we go.
Right, so you basically deployed an app to 3 different platforms effectively with very, very minor changes. So everything's consistent across all of them, and this looks like a super useful app.
It's actually more useful than it looks. I can actually zoom in and out and rotate.
Awesome. So the app operator then, in this case, basically they wrote their manifest. They defined the required environment variables, ingress traits, the host names. That means the developer doesn't need to know the difference between these 3 different deployments. And also it helps the delineation then in terms of application roles, the portability. Now you mentioned removing programming complexity. I think that's another part, another kind of chapter in this book. What's that about?
Yeah, so what we just talked about was about describing the app and deploying it, managing its lifecycle. The other project we announced is Dapr, Distributed Application Runtime, which is aimed at making it easy for enterprise developers to create distributed microservice-based cloud-native applications. This is how you'd write your application. And one of the things that we realized is that there's primarily 2 programming models or patterns that are actually take away a lot of the work that an enterprise developer would have to worry about and put that into the framework. One of them is the functions model. So functions as a service, stateless, event-driven microservices,
right,
which the platform will scale out, handle retries, and all of the kind of resilience that you want. So if one fails, it'll automatically restart it.
Yep.
The other one is for stateful microservices, and it's the actor pattern or actor model. That one is for when you've got a microservice where you want some state associated with a particular instance, and for it to be tightly bound to it. So the compute, it's kind of like object-oriented microservice.
Right.
And that also takes care of a lot of this plumbing and work that an enterprise developer would have to normally worry about.
So Dapr then, it's something new that basically provides all additional services here that you can leverage, for example, to be able to call into the various services and things that you need to have as part of your app, right?
That's right. So Dapr provides a bunch of building blocks that support the functions pattern, the actor pattern, and it overcomes, through a sidecar architecture, this limitation that you have with those existing implementations, the frameworks that exist today, which are they're very language integrated. So for example, most actor models only support C# and Java. But with Dapr's runtime building blocks, you can implement actor models in any language if you want to program to Dapr directly, or you can use a language integrated model on top of it if you want to.
Right, so why don't we talk about an example of how this might work. So I'll show a current way of doing things. So let's take, for example, an application that's running at the edge. And it might be a retail store, for example. And the application needs to track store inventory. It needs to allow customers to be able to check out at registers. So it needs a front end. It needs to be able to scan items and really communicate with other services. So then as you develop an app like this, there might actually be considerations, challenges that you need to worry about. Think common things like where do you save state? How do you configure your queues? How do you talk to or invoke other services? How do I activate actors for different workloads? So as a developer, I spend a lot of time then thinking about the plumbing, the different services I need to invoke, all these different kind of bespoke things, instead of actually coding the app. But how does this change then with Dapr?
Yeah, so before Dapr, you'd have to actually take care of all of the responsibilities yourself, which typically meant writing a lot of custom code or leveraging a bunch of different SDKs, having to learn each one of them to put that kind of system together. Now with Dapr, you're basically requesting these kinds of services or capabilities directly from localhost, because through this sidecar pattern, through HTTPC or gRPC if you need higher performance, you just ask Dapr for the functionality, the service, and you get it.
Right, so can you show us then what it would look like to actually build a Dapr-based application, given that as a developer, you're kind of giving Dapr the connection info, maybe like endpoints, but not all the different kind of all the drilled in resource bindings and those types of things, right?
Yep, so one of the goals of Dapr is to make it completely open so you can leverage the backing services you want to. So in the case of, for example, state management, you can plug in a state store. It might be Cosmos DB in Azure, it might be Redis on premises. And that way, with all of its capabilities, you can leverage the technologies that are the ones you want in the cloud environment you're in or the on-prem environment you're in.
All right, so I'd love to see how this can work in terms of building out one of these applications. So one thing that I love about this is basically like having your own in-house concierge. You're writing to localhost, but they're kind of getting rid of all the different things that you'd have to normally worry about because they're kind of, again, saying, okay, you need cache, we're going to give that to you. You need this service, we're going to give that to you as well. It actually attends to all your different needs, kind of like a butler in a way. That's hence the hat, right, in the logo.
Yep.
So that said, why don't you give us an example and show us what it looks like to actually build out a Dapr-based app?
Sure. So I've got an example of that retail app scenario you described earlier. I've got 4 different microservices in this app. One of them is this checkout microservice. You can see it's written in Python. It's using the Flask web framework. So it talks to Dapr again through the HTTP and leverages Flask to do the routing for it into the app. And you can see that it's got several different methods. Let's go take a look at the methods that it implements. One of them is add item to cart. So this would be when you're walking around, you're saying, I want one of these, one of those. You can see the product and the quantity, the number that you want, come in as parameters. Now what this microservice is doing is updating an a cache register here, a register actor, with a register ID that it's mapped to, calling it at add items method, and passing in the change in the state and the product quantity. You can see there's a get cart. Again, it's going to be using local Dapr state store to call into the register actor and retrieve that state. And then finally, checkout. Again, it's calling the register actor to do that checkout and say, I want all these items.
Got it.
Now, let's turn our attention to the second microservice, the register microservice, which is implemented using the C# SDK for actors on top of Dapr.
Okay.
Those of you that are familiar with Service Fabric reliable actors, one of the actor patterns that are out there,
right,
will see this shape of this interface looks very familiar. In fact, all we have to do, if you've got a Service Fabric reliable actor, is change the namespace right there from Microsoft.ServiceFabric to Dapr, and your code will just work in the Dapr environment.
Okay. Nice.
So let's take a look at the implementation of that interface here. Here's the register actor we were just talking about, and you can see here's the get card API. It's calling the SDK's local get state service, which is a Dapr provided service. Here's the checkout. Now, interesting thing about this checkout is that it's also going to be notifying an inventory microservice about the fact that these items are now being checked out of the store, so the inventory service can update the inventory.
Okay.
Then there's the save data, which is how that serializes its state, again using Dapr. Finally, the inventory microservice here, also a Flask microservice. And this one, as we already saw, that the register microservice is going to call it. So here's the get inventory for a particular product. And it's going to call into the Dapr state store, where it's just saying, Dapr, you take care of saving the information. I'm going to retrieve it here. Here's where it's setting inventory. So this is where the register is saying, for this product, add or subtract this quantity. You can see the math for that right there. You can see if the quantity is less than 5, calls this function, notify inventory. We'll take a look at it in a second. And then here's where you can see it's putting together the inventory and saying to Dapr, hey, go save that. Here's the state API for Dapr. So just you go take care of the details of how that's saved. And then here's the notify inventory function we just saw. Here's the Dapr URL. It's using now Dapr's pub/sub capability, just saying, hey, Dapr, you let anybody know that wants to know about an inventory change where inventory is low, that it's low for this product, and here's how much is left. And so Dapr then, just by this HTTP post, Dapr goes and takes care of that.
Okay.
Now what I'm going to do is run this all locally. So Dapr can work anywhere. It can work on this local dev box. This run command is going to use the Dapr CLI, launch those 4 microservices, and now I've got them running locally. So you can use Dapr capabilities whether you're building a single service or a distributed app. All of these are available for use. Now let me open up the browser. It should be started here. You can see I've got a local host endpoint here. So this is where Dapr is launching those microservices, and this is the front end for the store. We didn't look at the code for that, but this is where somebody, the admin, would see, hey, here's my inventory. Okay. And then here's the checkout app microservice. So this is where I can scan banana, scan apple, and checkout, and that would update the inventory as we saw in that flow.
Got it. So now we've seen kind of how we can build out the application, calling all the different services from localhost, from Dapr. And now we see, but we've got also Rudr. It's about deploying apps as well. So without changing the platforms, can we bring these two things together, kind of like peanut butter and jelly or peanut butter and chocolate, to have not only the app built in a way that kind of will work anywhere, but also deploy it anywhere?
Yeah, so I want to emphasize there are two different projects. You can use them completely separately. So you can use Dapr in a project and not use Rudr or OAM. In other case, you can use OAM and Rudr, but not use Dapr. But they obviously can go great together because you can describe the structure of the app using OAM and then deploy onto Kubernetes using Rudr, but you can implement the microservices using Dapr capabilities.
OK, let's see it.
So what I'm going to do is show you that I've got this app now wrapped up in an OAM manifest, application manifest.
OK.
So there's going to be 4 microservices. You can see if I search for component schematic, there's 4 of them. One for each of those microservices I talked about. You can see parameters here. This describes the full application. Now, I want to deploy it to 2 different environments. And this might be reflecting a real-world case where I'm going to do my dev test up in Azure Kubernetes service, but I'm going to do my prod here because this is in my store, so I'm going to deploy the prod environment here. So if I go take a look at the config file for my dev test environment, you can see that I've got an environment variable parameter here, dev, that the app can read out and know that it's the dev instance. And then at the bottom, you can see that I've got some metadata here, which is the binding for the state store, which I'm going to use when the app is in Azure. I'm going to use Cosmos DB. So those state store APIs I saw, Dapr is going to use Cosmos DB. Now, when I deploy it to prod, though, I'm going to want it to know that it's the prod version. And I'm also going to want to use some Redis, because Redis is what I've got on-prem. So I'm going to kick those off, those deployments, AKS, and there's the Pi. And then in a few seconds here, I've got some URLs here. This the dev URL, so this is going to be up in Azure Kubernetes service. Let's see if it's up and ready, and there we go, same portal. And so what Dapr has done with some of that metadata is injected sidecar into those Kubernetes pods as they got deployed. And now I've got the app, again, local dev, one box, if I wanted to deploy that there, and Kubernetes using OAM and Dapr. And so this thing is now portable across different environments.
Awesome stuff. Super portability. It's a really game changer, I think, in terms of being able to delineate the right roles and have anything run, whether it's local, in another cloud, in your on-premises data center. All these different things are enabled through this. Very cool stuff.
Yep, you've got these 2 new cools at your disposal. One's really kind of helping the developer interact with an IT pro that's managing infrastructure. The other one's, of course, developer-oriented. I think Dapr really is revolutionary in cloud-native programming.
Right. It's a great first look into what's coming for developers and for IT, and also for cloud-native applications. But how can folks get started?
So both of them, like I said, are open source projects. They're going to be going into open source governance at some point. You can check them out at their landing pages. For Dapr, it's dapr.io, and for OAM, which will take you to Rudr, it's openappmodel.io.
Thanks, Mark. And of course, you want to keep watching Microsoft Mechanics. If you haven't yet, hit subscribe. That's all the time we have for this show. Thanks for watching, and we'll see you next time.